Hello everyone, my name is Alshari Farmid and in this video I will walk you through my biostats project where I applied data analysis and basic machine learning concepts in Python. I will explain each step from importing data to training a simple re regression model focusing on the functions I used and parameters passed and the reason of each operation. Uh, I started by importing the necessary libraries using import numpy as np, import pandas as pd, import matplotlib.pyplot as plt. Then I loaded the CSV file using biostats underscore array equals uh, here delimiter tells numpy that data is comma separated, and I use skip underscore header equals 1 to ignores the first header row. Next I extracted the age column. This gives me all rows from the third column converted into float numbers for numeric processing. This step is crucial because clean numeric data is the foundation for any machine learning task. And then in question 2, to understand my data, I calculated the mean, median, standard deviation, minimum, and maximum manually using NumPy operations. Each of these measures helps understand data separate. For example, the mean shows central tendency while the standard deviation shows variation. These, dis- these descriptive statistics are part of exploratory data analysis EDA, which always comes before building a machine learning model. And in question 3, I used NumPy built-in methods like np.mean, np.std, np.min, np.max, np.percentile. I calculated the 30th and 70th percentiles to understand the data is distributed, to understand how the data is distributed. Percentiles are very useful in feature scaling and outlier detections, helping us to see where most of our data point lies. And next in question 4, I visualize the age column with plt.haste ages beans equal 10, color sky blue, age color black. Here beans equal 10 divides the age into 10 equal groups and color plus age color improves readability. Then I added vertical lines for the mean, median and percentiles using plt dot avx line color rate and line style dot sorry underscore. These lines visually show where the data centers and spreads. Visualization is an important part of data understanding in any ML pipeline. And next in question 5, I covered height and weight into metric units. This uses NumPy broadcasting, allowing operations across array without loops. Then I calculated BMI, and I normalized the ages using z-score normalization. Normalization is key in ML because it ensures that all features contribute equally to model training. Next in question 6, I created logic mask to filter subset of data. Then I used this mask to calculate counts, averages, and medians. This method is called Boolean indexing and it's much faster than loops. In machine learning, this is often used for data segmentation such as separating training and validation groups or filtering a specific population. Next in questions 7, I built a simple linear regression model to predict weight on kg based on age. I install uh, scikit-learn. I split my data using x underscore train, x underscore test, y underscore train, y underscore test equal train underscore test underscore split test underscore size equals 0.2 means 20% of data is for testing. Random underscore state equals 0 ensures consistent results. Then I trained the model um, linreg.fit x underscore train comma y underscore train and made predictions to um, evaluate performance. I use uh, for com, this one to evaluate the performance. Finally, I plotted the regressions with line p plt dot plot line underscore x comma line underscore y comma color equals to red. This one. This shows how well our model fits the real data points. This step demonstrates the supervised learning process, training a model to learn a relationship and testing how well it predicts. Uh, in my assignment, each function call played a role in preparing data for modeling, a vital part of building accurate and ethical machine learning system. Thank you for watching.